Good morning, all. A warm and cherished morning to our most valued participants. I, Dr. Sania Ansari, the event coordinator, would like to thank you for showing keen interest in joining and attending the 5-day faculty development program on the artificial intelligence. All the sessions were very good, and each of us present here and enjoyed it. I would like to express my gratitude to our speaker, Mr. Kushal Sharma, for his explanation and giving the excellent coverage to the artificial intelligence. I would like to do here one important announcement. We'll share the quiz based on the topics covered in the last 5 days, in these 5 days of the FDP at the end of the session. So kindly fill and submit the same till today evening. Also fill the feedback form which we are going to share during our session or at the end of the session. Tomorrow we'll distribute the FDP certificates on the email ID which are mentioned in the registration form. So kindly complete your this quiz form as well as the registration form, and definitely tomorrow we'll email the certificates. Those participants have attended the FDP regularly as well as submitted their feedback forms, and then those who have submitted their quiz form. So we thank you once again for being with us. It was a great pleasure, and thank you very much. We'll start today's session. I hope Mr. Kushal Sharma is with us.
Yes, we can start.
Yeah, Kushal, please you can continue. Thank you.
Okay, thank you. Thank you. Good morning, everyone. So let's begin for today's discussion, and let's start with the library, which is RDF. Okay, let's start with this. Okay. Yes. So this is Rdf library, and it is basically a resource description framework. So let me just make it here. Just a second, what's happening? Okay, yeah. So this is where is it? Fine. Okay. So this particular library will help us to identify or to extract information from the web sources, and by extracting the information, it will also represent it into different you can say namespaces. So there's a concept called as namespace. Yes, so let us try to explore this library here, and try to create some graphs out of it. So for example, like we have HTML representation of some data. Similar way, this will help us to extract data out of, for example, like XML we have, so we can extract data from there. Okay, so let's try it out and do some operations on it, and then we will move ahead for some as per our yesterday's discussion. We will move ahead and we will work on some algorithms and models and try to evaluate them also. So let me start now. Yes, so I have done pip install rdf lib. So this is how you can install. Here I have, you can see I have here this Anaconda PowerShell as well. So if you want to do the setup of any package, you can install. Anaconda can be one of the like best options to manage out packages. So Anaconda gives you PowerShell or Anaconda shell, using which you can install, uninstall, or upgrade packages. So from here you can do that. Anaconda also gives a navigator. So this navigator gives you a user interface with the help of which again you can manage the packages. So whatever way you feel comfortable, with the help of a UI you can do, and with the help of the command line also you can do. So any ways, both ways you can actually work with Anaconda. And yes, so otherwise you can directly install any library from the Jupyter notebook as well. If you are using Google Colab, there also most of these commands will run. So directly you can run pip install and the package name. They will help you with the download. So this is how you can download and install the library. And after that, you can see here I have yes, I have here from Rdf lib, I have imported graph, literal, Rdf, URI. So I have imported different packages from there. Okay, and here we have some more packages. So from rdf lib dot namespace import foaf xsd. So different packages we have. These packages are basically coming under knowledge representation, that how the data can be extracted from some place, or how we can insert the data and present it in a form which can be easily understood. So these are those type of packages. Like FOAF is again a machine readable package which can help the computer, the machine, to understand the entities, or you can say, let's say person is there, so machine will be able to understand person and other objects, and also their activities. So these packages will help the machine to understand the real-time objects and their attributes and their actions. And then we are creating a graph with a graph object with the help of g is equal to graph. Then after that, yes, here we have different formats. So I just found this turtle format was good enough to basically read the text after we are doing some right after we are inserting some data. So here, let's start from here. Here you can see that what we are trying to do. Let me create a new cell so that it is more clear, and everybody is able to understand. So the required packages we need to import. So the packages, you can go and always read about it because they are very vast. So the more you read, you will more be able to understand about each and every sub part of the modules and packages. So from rdf lib, I can just take these two lines from here, okay, the import lines. And yes, so we will import these packages. And after that, now we will start here. Let me create a graph. Okay, once again I'll create a graph here. So g is equal to, I'm creating a graph with the help of the graph class. So yes, so this is how. And then I can create a namespace. Okay, so namespaces will identify different entities. Okay, different entities. Let me show you how now. take namespace as one domain. Okay, so for example, I will write it as, let's say, ns1, okay, namespace 1, or I can write it as ex1, example 1. Okay, so in first namespace I'm creating, so with the help of namespace class I can create, and inside that what I will do, I will be writing some dummy URL. Okay, so I can write http colon slash slash, and I will write, let's say, I'll write my website's name, indeed inspiring.com. So some URI I have given here as of now, and after this, so graph is created. Okay, so this is a graph, and we have a namespace created, namespace. Okay, two things we have created. Now in the graph I would be adding some person, their activities, with the help of namespace. Okay, so in the graph
Sorry.
G I would be adding, yeah, so in the graph G I would be adding some entities and their activities with the help of namespace. So you can see here how will I be doing that. So G dot, so we all must be aware of that dot is the operator, which is a relationship operator. So G dot add, I will be utilizing the add function. So G dot add, and then inside that I will be using ex1. So ex1 is the namespace. Okay, so I'll be using ex1, and dot, here I'll be using, let's say, one person, and the person is let's say the person name is Raman. So Raman is the person name, so ex dot Raman, and then I can write here ex1 dot action. So the action is runs runs. Then second I'll write here ex1 dot company, company. Okay, so what happened here, you can see I am trying to write ex1 dot raman, comma, ex1 dot runs, comma, ex1 dot company. So I have tried to tell that company and Raman are two entities, two person, and we want, and there's a relation between them, that the first entity runs the second entity. So Raman runs ex1, it is like that. Raman runs company, it is like that. Okay, so let me just take the display. Yes. So print g.serialize format turtle.decode. Let us print this and try to see what does it show. So add takes two positional arguments, but four were given. Okay. So here if I see, I need to put all this into a single bracket. So let me just put this into a single bracket and then run it again. So here you can see that, yes, yeah, let me, yeah, so you can see after that it is sticking up. So let me put a slash over here. Yes, correct. Now let me execute. Okay, yeah, so now you can see namespace 1 ns1. So under namespace 1, and this is the URI. Okay, this is the path, and under that we have here ns1 raman, ns1 runs, ns1 company. Okay, so under namespace 1 we have three things: raman and runs and company. These three things are there under namespace 1. Now let me create certain more um such uh, uh, entities. Let me add it to the graph, and let me do g dot add, and let me add ex1 dot, and now I would be adding, let's say, his age. Okay, so raman raman, and then I can have ex1 dot age, and then I can just pass a literal value here, literal. So there is a provision of passing a literal value, and inside that I am passing 26 as age, and after that data type is equal to, so this is yeah, so this will come from xsd dot integer. Okay, now let me represent this. Yes, I'm just doing the same thing again. Let me just put it as a single element inside it, so it needs to be a single element. Okay, so here we can see that, yeah, so ns1 and Raman's age is 26, and Raman runs company. So you can see the kind of hierarchy which has been formed, and we are able to interpret or understand from the hierarchy that there is some entity Raman or some person Raman, and the person's age is 26, and runs is coming. You can see indentation, so it is coming here. Okay, so Raman is running, okay, it is running some company. Okay, so this is something which we are easily able to interpret. Okay, so similar way, whatever relation you want to create. Okay, now let's say Raman gets married, so I will write Raman dot add, and inside it I will write ex1 dot Raman and ex1 dot marry, and or married, and I can write ex1 dot say Roma. Okay, so Raman married Roma. Now you can see that again the indentation is at same level. You can see that. Okay, so we have Raman, and Raman's age is 26, and Raman married Roma. Okay, and Raman runs a company also. So this is how the knowledge is getting represented. This is one example of Rdf library. Okay, so which can be used to represent the sentences without losing their meaning, like this, in this format. Let's just add one more thing here. So if I add here for Roma, so ex1 dot Roma, and ex1 dot age, and let me write here again as literal as, let's say, 25, and data type is equal to xsd dot, let me execute this. So here you can see that Roma becomes, you can see there is a gap here. Just look at the representation, and indentation comes here. Okay, so now Roma is a person of same level as Raman, and now whatever we will write for Roma, that will keep on coming under this. Okay, under this particular entity Roma. So this is one library where we can put details. Okay, if you want to, let's say, further going, if you want to add there certain more things. For example, let's say Raman lives in Delhi, so we can represent it as, for example, g dot again add, and here ex1 dot, so Raman lives in Delhi, so I'll have to write Raman. Okay, and I'll have to write ex1 dot, here I can have the lives in. Okay, so this is the relation lives in, and then I can have here ex1. So either I can have a literal. Okay, I can just put a literal over here. Okay, that is one thing. So let me put a literal. Inside literal, the whole address can be put. Okay, so I can just put DELHI Delhi INDIA India. So here you can see under Raman only we have this lives in Delhi, India, this way. Okay, so similar way you can keep on adding for Roma as well. You can add, okay, that where does she live. You can add the complete address as well. Fine. Yeah, so yes. Further going, if you want to show some, let's say, yeah, let's try date of birth. Okay, date of birth, let's try that. So if you want to put date of birth, so you can put it like this. So g dot add, and again, so we have again ex1 dot Raman, and then we can have ex1 dot, and here we can put the BIDOB, maybe date of birth, and then we can have a literal here, and inside the literal we can mention the date of birth. Okay, so let's say it is 19 maybe 90. Okay. Yeah, so if it is 1990, 1990, 5 or 6, 6. Okay, so yeah, 1996, then let's say 01 and 01. Then yes, so this is literal, and then we can mention that the data type is date. So data type is equal to xsd dot date. Okay, so here we are able to see that this is the date of birth. Okay, yeah, all good. Yes, all good, correct. So this is how this rdf library can help us with representing the data, like we were discussing about ontology and propositional logic. So this is coming under ontology, that how knowledge can be represented. This is one library. Similar way you can find other libraries also which can help you reading the data this way. Fine. And to bring data from some place, you can just use URI. And where is that example? Let me show. Yes. So here we can see that yeah, it is similar example. Okay, but here more complex. rdf.type fof.nic. Okay, this way it has been used. So yes, printing raw types. Okay. Let me just comment this, and let me execute. Let me just take all this there. Okay, let me take it here. Yes, let me execute now. Yes. So now here how it has basically represented the whole information. So yes, importing, creating a graph, and here we are using Donna is equal to URI reference. So earlier we had created namespace. Here we are creating a URI reference. Now here we can add, so g dot add Donna rdf dot type fof dot person. So in this case, yeah, so in this case, if we see, so rdf dot lib dot uri ref, So it is coming from HTTP. Yes, from here. Just a second. So let me just confirm on this. Yeah. So yeah, this is HTTP. Okay. Okay, fine, got it. Okay, so just look at this. So this is coming from only this much. Okay, yeah, so here we have created two. One, if you see, we have created this one, ed is equal to URI ref and http colon slash slash example.org. So this is something you can give anything, okay, because this is not going online or checking anything. It is not doing anything of that kind. So you can do any such URI you can give, okay. When you are using some real time, then you can use some real. So this is just for an example. And here we have created one person, that is Edward, and here we have created one person as Donna. So we will be able to see details of both. So here we are able to see that Edward is there, and then uh, here it's details 0.1 person, and then second, if you see, where is the Donna? Yeah, it is here. Just a second. So here, just a second. So I'm let me just uncomment this as well. Yeah, this is format this one, and let me just take the format of. And the graph name is G only. Okay, so okay, yeah, so this is better representation, then we will interpret that. So this format, this is again N3 format. Okay, so I can TURT. Okay, yes, fine. So in this format, we are able to understand that there are two person. This is one, okay, and this is two. There are two person, and then if you try to interpret, so first person, here we can see uh, this is for http colon slash slash example.org Donna. This is first person, and here this is Edward. This is another person, and then mailbox email is this. Then name is Donna Fails, and nickname is Donna @ed. And similar way, here if we see, uh, this is the first person, mailbox is mail to, and then this name is Edward, scissor hands, and the nickname is Ed. Okay, so this is how we are able to understand other formats. I have not much explored these formats, so we'll have to explore. Okay, so here you can see, you can just change that which format do you want to see. So like N3 is the format, this format if you want to see, or if you want to see in raw formats. Okay, so whatever way you want to see, so this is the raw format, how it has organized internally. But if you want in human readable format, so this turtle is better. N3 is also good. So these formats are good, and we can understand. So these two formats are basically similar, and more human readable. Fine. So this is one library which helps us to represent the knowledge in the form of it stores in its own format, but we can see it and interpret it by representing it in different formats. Now, yes, so this was from that knowledge representation. One example I just wanted to include here, RDF library. Yes, now I will take you to some example codes of machine learning, because we wanted to discuss that how algorithms work, how to decide that which algorithm to choose. So let me take you there, and I have taken some of the codes downloaded. Let me just start them and we will try to see them. Hmm. So let me extract it to C and users and here. Okay. Okay, fine. So let me go to this homepage and okay, fine. So we have, yeah, so whatever I would like to show, I can take it from here. Okay, fine. Now, before taking this, let me take you through a concept of artificial neural network. Then we will try to explore it, and then we'll try to see more algorithms as well. Now, artificial neural network, in the beginning, we had discussed that under data mining, we have artificial intelligence. Under artificial intelligence, we have machine learning. Under that, there's the specialization called as deep learning. And deep learning completely works on artificial neural network. So the learning part of a model of an agent, so there ANN, artificial neural network, plays a very important role. So let me take you through this, and then we will see some simple artificial neural network. We'll start with that, how to create them. So yes, as we had already discussed that the artificial neural networks, ANNs, they are made up of neurons. So neurons are coming from human neurons, human cells, and here we can call them as units or nodes. So when we are writing a program, so we can either call them as units, a single unit, or number of nodes. And the functionality of these nodes or neurons is they receives input. So once they receive input from the environment, then there is a change in the inside that neuron. Okay, so we call it as that neuron was in some state, and the state is now getting changed, and this change of state is called as activation. So this activation brings out some output. Okay, so this activation brings some output, and that output signal is sent to the next cell. Okay, so once again I'm saying, so we can take here as, okay, fine, yeah. So let's have this through. Yes. So here you can see that this is an example of human neuron, and it has got different parts. One is dendrites. So these thread-like structures on the cell, this is the cell, you can see these thread-like structures, they are dendrites. So they receives the input. If you touch a hot plate, so you will receive the input through these dendrites. Then this is the cell body, this center part you can see, this is the cell body. This is like processor. Okay, this is also called as soma. Inside it we have a nucleus, so we are not much interested about nucleus as of now, okay, because we have this cell body where the which can be synonymous to the activation function which is happening because it is like a processor. And then we have these synapses. These synapses are links to other neurons. Okay, so we have one single cell, it is linked to hundreds, more than hundreds, maybe up to thousands of neighboring neuron cells, and that connection or that link is established by the synapse or synaptic link, you can say it. And the output, because these dendrites they give the input, and the output is given by the axon. So you can understand, input is taken by the dendrites, output is given by the axon. So how does it really happen? The axon is giving output to the dendrites of other cells, okay, to the dendrites of other cells. Okay, so wherever this connection is happening, that is called as synapses. So this axon is getting connected with the help of this synaptic link to other cells, and it passes the message. And it is so instant that you agree and understand that within some microseconds the decision is taken and the action is performed. Okay, so that is how it does happen. Now, this is what we were discussing here in the first slide, that the cell has a mechanism to receive input, and as soon as it receives the input, there is a change in the internal state. So that change is called as activation in terms of artificial neural network, and then basically it sends one output signal to many other output neurons, possibly including its input neurons, recurrent neural network. So possibly including its input neurons, that means this axon can send the output to itself as well. Okay, so it can send it to itself as well. So that is also a possibility. So the output sent by through the axon can be received by the same cell as well. Fine. So this is very basic and primary behavior of a neural cell we have just discussed, that how these neural cells behave. Now, the information is transmitted as a series of electric impulses. So this is called as spikes. Okay, so the information received will be transferred in the form of electric impulses to the other neurons. Okay, and the frequency and phase of these spikes encodes the information. In biological system, one neuron can be connected to as many as 10,000 other neurons. So now you can understand the capability, that information, how frequently it can transfer, because as soon as one neuron has transferred it to the other one, this simply means that the other are 10,000, and 10,000 will pass to another 10,000. So within microsecond, like lakhs, more than lakhs of few lakhs of cells will be aware of this, the message first has passed. Okay, now just for information, so there is a confined area where the information can be received. It is not that everywhere information can be received, so that is called as receptive field. Okay, we know this thing, no need to discuss that thousands and thousands of thoughts are getting processed within the brains, so no need to discuss much on that. Okay, now why neural networks to be created? Why do we need to understand like how human brain functions? So basically we have intention to create computer programs which can behave and act like that. So that is the objective we have, that we can solve complex problems. Now this is the architecture, let us understand. This is the architecture of the neural network, and here we can see in the diagram, we have layers and there is a flow. Okay, from left side to right side you can see a flow that how the information is flowing, okay, from x to x2 to x3, okay. So all these circles, they are basically uh, your neurons. They are actually your neurons, okay. And the information passes from them and reaches to second layer, from second to third layer, till the output is decided, okay, till we decide that where is the output. Fine. Here, if you see that from the input layer till the output layer, we have one more layer in between, and this is called as hidden layer. So terminology wise, I believe everyone is clear now. We have input layer, we have some hidden layers, one or more hidden layers, and we have output layer. All the layers are consisting of some circles which are called as nodes. So all of them are connected through nodes, okay. And nodes are basically having some sort of activation function, and that activation function helps the input to be processed and output to be given, that we will understand. Okay, we have multiple types of neural networks like feed-forward neural network, radial basis neural network, and coherence recurrent neural network. So we have these few types of neural networks with us. Let's start with the simple feed-forward neural network. The simple feed-forward neural network, this is coming from a concept where you have only one input layer, and from that input layer you are giving the output, okay. So you can see here the black dots are represented for input layers, and from that input layer you are yeah, so you are simply giving the output. There are no hidden layers in this case, okay. And hidden layers, even if there are hidden layers, okay, then also what difference you will find here is you will not see the direction which is going towards backward, okay. So it is simply the data is getting input to one node and or a set of nodes, and from there the data is getting into other nodes, and it is kept on moving forward. So it is unidirectional, on one direction, okay. The data is not coming back, so therefore it is called as simple feed forward neural network, okay. Then we can have one variation of this where we can allow the back propagation, okay. So back propagation is also useful. Like somebody was asking about optimizations. So how optimization happens? Optimization happens with the help of back propagation techniques, okay. So what happens in optimization, I'll verbally just explain here only, and then later on we will see. So in this case the input is flowing from this direction, and here we are getting an output, okay. So in paint it will be very easily understood how it is happening. So just give me a second. All right, yeah. So here we can see that yeah. So I think I'm here. Yes. So in this case, we have input, and that input is getting into a node, and it is helping us with an output. Okay. So this is a kind of structure, simplest structure you can think of. So here we have x, and here we have y. Okay. So x and y is there. Now this is simple feed forward. Now if you have, let's say, the output coming here, and we have the supervised labeled data. So here we have x and y as well, and consider this as let's say y dash. Okay, so let's treat it as y dash. Okay, so we have x and y, and we have y dash as well. So during second day, I believe we were discussing on it, that if you want to identify what is the error, you can identify by y minus y dash. Okay, so this will give you the magnitude of the error. You find the absolute values, and you'll get the magnitude of the error, and your objective would be to reduce the magnitude of the error. Okay, so if your objective is to reduce the magnitude of the error, in that case, what would you like to do? You would like to apply some technique, and now the technique you can apply here is back propagation. So you can go like this. So whenever you are getting y, you send this y back here and make some adjustments. And I hope we remember that where we need to make adjustments. So we have an objective to find y is equal to f of x. So we are finding a mapping function between y and x. So in that mapping function, we need to make adjustments so that the y dash is very near or same as y, and the error is reduced. Okay, here there can be two problems. One is basically, if the y is exactly getting same, if the y is exactly getting same and y dash with y dash, that can be one thing. Okay, so that always we can have y dash is equal to y. Okay, and this is true. So always we are getting this as true, always. And there can be a case that we are getting this as false. Again, always we are getting this as false. So in both the cases we have a problem. Okay, so here if we see, it will become overfitting, and in the second case it will become underfitting, because we are never getting y dash is equal to y. The actual observed output and the predicted output is never same. In that case, it will be underfitting problem, that still the y is equal to f of x. The mapping function is very immature. But if we are getting like this, that it is always true, then in this case, whenever you will get some new sample data to be tested, in that case you will face challenges. Why you will face challenges? Because it will only give the correct answers for the data for which you have trained the model. It will not give, like, there are very high chances that it will not give the correct answers, correct predictions for the new sample data which you are going to input. Okay, so this is important. Okay, this is important that we need to have an optimized way. So we need not to make the error as zero. That is not the objective. We need to minimize the error. That is the objective. And again, this depends from problem to problem. Okay, machine learning is not a is not like for example just a linear regression. Okay, it's not like just y is equal to mx plus c, that's it, nothing else. It's not like that. So here basically we have plus some epsilon. Okay, so let me write just E. So some error term is also there. So we need to make adjustments to that error term, or there is a concept of weights. We need to make adjustments to those weights, and that actually brings out the, yeah. So Navneet, you are requesting control. So do you have any questions? Okay, I think it might be by mistake. Yes. So here we need to formulate that function. Okay, so we need to work on a model, and model will perform its trial and error and will come up with a optimized solution. Now going back here, so this is an example of a simple feed forward neural network, and as I said, we can have a back propagation also included in this. Now this is radial basis function neural network, RBF. So RBF is, here you can see, it considers the distance of a point with respect to other center. So let's have a observation to the diagram. So what it is trying to do, and then try to understand. So here you can see that it is calculating distances from some points. Okay. So yes. So radial basis function considers the distance of a point with respect to the center. And even the centers might change. Okay, the centers might change. It is not like that centers will always remain same. So it has got two layers. First layer where features are combined with RBF function in the inner layer, and second, the output of these features are taken into consideration while computing the same output in the next time step, which is basically a memory. So now you can understand what we were discussing here in this case, that we need to have a back propagation that we are able to see here as well, that first with the help of, initially with the help of the RBF function, we will be able to, yes, we'll be able to combine the features. Combine the feature means here you can see that this becomes one cluster, this becomes one cluster, this becomes one cluster, this becomes one cluster based upon some distance formula. So we combine the features, and then the output of these features are then taken into consideration while computing the same output in the next time step. Okay, so that means that is what I was trying to say. Why that output is taken? Because in the next time now we have some learning which has happened. Okay, with the help of that learning, the next output will yield better results. Okay, so therefore that is added here. Another type is coherent self-organizing neural networks. Okay, so they are also called as SOM, self-organizing maps. And here the objective is to input vectors of arbitrary dimensions to discrete map comprising of neurons. Now here, the map needs to be trained to create its own organization of training data. It comprises of either one or two dimensions, otherwise it will become too complex. Yes, now while training the map, the location of the neuron remains constant, but the weights differ depending on the value. Okay, so it is 1D or 2D maps, and here, yes, what we are trying, the location of the neurons are the nodes, they remain same, but the weights, so I'll tell you more about weights in some time. Weights are there and biases are there. They are basically, they can modified, they can be changed. Again, here also the back propagation happens. So just in the simple feed forward, the back propagation will not happen, but in RBF, in coherence, back propagation is going to happen. Okay. Then, yes, so here the explanation is given on the same thing. So in the case of coherent, at the beginning, some small weight is given to the input. Okay, so input vector or the input data is there. So to that, we give small weight, and then in the second phase, the neuron closest to the point is the winning neuron, and the neurons connected to the winning neuron will also move towards the point, like in the graphic. Okay, the graphic which we have seen. Now the distance between the point and the neurons is calculated by Euclidean distance, or here Euclidean distance, like in other algorithms we have Manhattan and other distances also, and the neuron with the least distance wins. Now this is iterated multiple times, like we had seen in KNN algorithm on the second or third day discussion, and all the points clustered. So yes, all the points are clustered and each neuron represents each of its own kind of cluster. So here what is happening? Here basically, here here you can see on the basis of distance calculation, points are getting clustered. So one cluster represents one type of entity. Another cluster represents another type of entity. Fine. So with example, one program I will demonstrate even on cluster as well. Then we have RNN, that is called as recurrent neural network, and this is mainly used for one of the major application of RNN is if you see Google or Gmail or LinkedIn, they keep on giving us suggestions like if we start typing. So better example is Google. They have optimized it a lot. So if you input a word and then it will give an output, and that output is the next word you probably would like to type. So Google does it a lot in Gmail, and whenever we start typing, so if I type please find the, so it will automatically write attachments, or if I write attached, so it will automatically give the suggestion as attached files. Okay, so this is basically long short-term memory. This is on the basis of long short-term memory. Okay, so it tries to capture as much as information possible. Okay, but for short term. So this is the behavior of recurrent neural network. Now, works on the principle of saving output of a layer and feeding this back to the input to help in predicting the output of the layer. Then we have CNNs as well, convolutional neural networks. So CNNs are specially helpful in signal processing and image classifications. So that is where is the area of CNN where it works. So whenever you want to work with images, so you can you can start working with CNNs. Okay, and then we have modular. This is like you can have hybrid approach. Okay, so modular neural networks have a collection of different networks working independently and contributing towards the output. Okay, so you can have multiple neural networks working together. Okay, fine. So this was just an introduction to different types of neural networks we may have. And let me just start with a simple demonstration of a neural network. So here I have, yes. So let me have a simple example first. Okay. So the way the neural network works, it is basically demonstrated with the help of manual codes. No library has been used in this particular example. So as I said, there is an activation function in which plays very important role, because activation function helps us in bringing out the kind of output, whatever output we want to get, that comes from activation function. And then if we want to include back propagation, so that can be done with the help of derivatives, or you can have some more functions for creating the back propagation. So here in this example, I have used simple pandas and numpy libraries. I have a function here. It is a sigmoid function which is returning 1 divided by 1 plus np dot expx. Okay, so whatever will be the x, okay, whatever value is there of x, we are returning it 1 divided by 1 plus e raised to minus x. So np dot exp minus x means e raised to minus x. Okay, so these functions, okay, the sigmoid function. Then in neural network we have multiple functions. We have ReLU, we have rectified like we have leaky ReLU. So ReLU is rectified linear unit. We have tan h function. So multiple functions are there. So to start with, sigmoid can be used, but ReLU is very much being used, and yeah, certain other functions are there. Like they can be applied as per the kind of use case we do have. So here Yes, so initially we have defined the this particular sigmoid function. We have created it. So here, okay, and then the kind of behavior that sigmoid function does, that can be graphically viewed over here. So this is a kind of function, sigmoid function behavior shows, and you can see that it is giving us a value from 0 to 1. Okay, it is not exceeding 1, it is not going down from 0. So whatever may be the input, it is going to give us a value range of this. So this you can either take it as for example, you can take it as like this. If you have two class problems, okay, and you want to identify which class a particular data point belongs to, so that problem can be solved by this particular function. So what this particular function will give as output, so it will give as output a probability that it will give output. Let's say it gives this particular place as output, okay, and this is the center line we have. This is the center line we have. This is the threshold we have, and this threshold tells us, this is threshold, okay. So this threshold tells us that above this, okay, above is okay, class 1, and below is class 0. Okay, so the above all like those which will which are having more than, just a second, all those which are having more than the threshold value, they are in class 1, and rest of them are in class 0. So this is what this function output signifies. The value whatever we get as the output of this function, it signifies that which particular class it will belong to. Okay, then here we are taking a scenario, and the scenario is that we are taking three subjects. One is science, another is social science, another is maths. Three subjects we are taking as scenario, and like normally if we will talk, okay, so we have science, we have maths, we have social science, okay, social studies, let me write. So what is your opinion, like science, okay, and maths and social studies. So we want to tell to the student, okay, that what is the, like what is the likelihood, or let's say we should say it like this: how strongly are we recommending you should go for a mathematical course or a science course, like engineering or BSc in computer science, or so any graduation which is requiring mathematical skills and technological skills. So how likely are we going to recommend or insist the candidate to go for it? So what do you think, like for science, the student, like out of 100, or let's say 0 to 1 is the value we need to give. So I believe at least 70 percent. Okay, so 70% we would like to have that child should score. In maths also nothing less than 70%, or maybe if leniency is given 65 plus, still he will feel challenges. And in social studies, we may say ignore it, okay, because this doesn't affect the science part. Okay, this may be our notion. Okay, so here we can see that if three subject marks are given, then we cannot consider all of them with equal value or importance. So we need to give some sort of more importance to science and maths, and social studies can be given very less importance. The only thing is the person should not get failed in social studies. He should just pass. That should be the criteria. Otherwise we are good, like if he is not very good in social studies. Okay, so this is something is the scenario where we need to give some weightage also, that based on the weightage like more preference will be given to science and mathematics marks, and less preference will be given to social studies marks. Hmm. back here. So you can see that this is what is the scenario we have taken. Zero is that we are not recommending, one is we are recommending. Okay, so zero means we are not recommending, one means we are recommending. Okay, and any value between them, that will basically tell us the strength, like how strongly are we recommending, or how poorly, like how we are saying no, no, don't go for it. Okay, now for that purpose we have not I have not taken here any huge data set. Here we have taken only small pieces of data. So you can see this is basically small piece of data representing values 0 to 1, and these values are basically representing scores of different students. So scores of different students are in front of you for science, maths and social studies. Let me just correct the sequence. Science, social studies and maths, this is the sequence. Okay, remember the sequence. So the marks are for science, social science and maths. These are the marks for them. And then we are telling that particular individual child, that how what is our opinion on him going for such education. So we are saying 010, we are saying don't go, 0% recommendation. Then for 001, who is very strong in maths, we are saying 75, go with it. 100.5, go for it. And yes, and the last one, 110.5 and 111, we are giving 1, that yes, we strongly recommend that you should go. Okay, so this is the initial data set, and you can see X and Y both are present. So this is labeled data we have. Okay, it is labeled data we have, supervised approach we have. Okay, so let me execute this, and now, yes. So here we have three important things. So np.random.seed, this is basically a function of Python which will set a seed value as 42, and it will generate random values, and the random values will be generated in a same sequence. Understand? Like every time we do execute, some default seed value is set, and based upon that seed value, the random numbers are generated. But here, if we are freezing out the seed value, it will generate same set of numbers, so that quality will be maintained. Okay, fine. So here, weights, bias and LR, three important things. Okay, weights are basically, as I said here, I don't want to give much weightage to the social studies. Why should we give much importance to that? Whether the child is getting very poor into that, and you need to rescue, like you need to help, then basically, yes, so like very poor in social studies but very good in science and maths, you can allow him to go for engineering. Okay, so therefore we need to give less weightage to social science if we are planning for engineering. Okay, we should give less weightage for science if we are planning to go for arts and other things. So therefore weightage is important. So initially some random weight has been taken. Listen, just look at here, some random weight. So it will create three weights. Okay, one for science, one for social studies, one for maths, randomly. After that, you can see a bias has been taken. Bias is simply error. Okay, some sort of error. After doing everything, there is a probability that we may have error. So bias is nothing but bias is that error. And after the bias is there, then we have a learning rate. A learning rate is that by how much rate we should tweak the parameters. We will be tweaking the weights and biases. So you can see that it is very low, like 0.05 we have taken. So learning rate needs to be very low so that we can observe. So again, like here you will see that optimization will happen. So we may not be able to discuss lot of optimization techniques. I'll be telling you the approach here. Okay, how we can, the approach theoretically I told you, and we'll see here the same approach, like with back propagation and reducing the error magnitude. That is one of the way that we can optimize the algorithm, and we can have a better model created. Okay, so here three things we have: weight, bias, and learning rate. Let's move ahead. Let me execute this, and yeah, once again the same sigmoid function and derivative. This is for back propagation purpose, and then here you can see we have again for each epoch in range 2000 20,000. So 20,000 times we are going to run this. And how we are running this? Inputs is equal to feature set. So the whole data of input that has been taken here as a input set, and xw is equal to feed forward step, and then there is a back propagation step. Feed forward step, it says that np dot feature set and weights plus biases. Okay, so what is the formula? The formula is feature set. Feature set is your this thing. Yeah, this part. So this part is the feature set. Okay, fine. So here you can see feature set has been given into a new variable, that is inputs, and then we are trying to find out xw is equal to np dot feature set comma weights plus bias. Okay, so we are doing this thing dot product, and we are adding plus to it. Okay, and it will come up with some output, okay, with some bias. So weights we ourselves had created, so some output it will come up as. And secondly, this we are putting it into sigmoid is going to give us output, whether that person is having 0 as output or 1 as output, or it will give some value. Okay, that value is near to 0, or that value is, yeah, so is near to 1. Okay, that is something this sigmoid function is going to output. So if we have only this much, understand, if we have only this much, this is simple feed forward neural network. This will become a simple feed forward neural network. But we want to check for the errors, and we want to work on the errors. So let me execute this, and then I'll show you. Okay, this is very simple example. I'm executing this, and I'm printing the errors here. So here you can see in the back propagation, error is equal to z minus labels. So whatever output we have got, and we are subtracting it with the labels, the kind of labels we have. And after subtracting it, we are getting the below errors. And now we need to look at the errors, and we need to identify when is the minimum value of the, yeah, so what is the minimum value of the this thing, the what is the minimum value of the error, and that is at which iteration. So here if you see, it has kept on reducing the error, it has kept on reducing the error. Okay, and after certain time you can see it has come to 008 and continued and continued. Then you can see the error has been very much minimized, right? So almost error is, okay, so let me just go here. Okay, it has displayed here only. Is it not ending? No, it's okay. Yeah, fine. So yes, so here you can see the error has been minimized to 0.003. So how does it happen? Because we iterated it so many times. Okay, therefore the error has got reduced. So now what I have here, you can see, yes. So for error is there, print sum of error, we are printing the sum of error, we are not printing single error, that is the sum of error. And then here back propagation step 1, we are finding the error. Step 2, dcost underscore dpred is equal to error. Okay, and then dpred underscore dz is equal to sigmoid derivative, and there we are putting the z. Okay, so what is the z? Z is your output given in the previous step, okay, in the current step for now. And hmm. So here you can see what has happened. Here we have tried to identify the Z delta. Okay, delta is a small change in, okay, and that small change we are able to see d cost from error into finding out the derivative of the output. So we are finding the derivative of the Z, and we are multiplying it by the error, and that is giving us some sort of magnitude that is stored under z delta, and then we are using that z delta. You can see input is equal to, here you can see input is equal to feature set dot transpose, and weights is equal to minus weight is equal to weight minus learning rate into np dot dot inputs dot z delta. तो input और z delta यहाँ डाल दिए, और learning rate के आगे आपने हाँ लर्निंग रेट के आगे आपने माइनस कर दिया उसको विद द हेल्प ऑफ वेट्स. सो दिस इज गोइंग टू गिव यू अ न्यू वेट. एंड बायस आपको कैसे अपडेट करें फॉर नम इन जेल डेल्टा. बायस इज इक्वल टू बायस minus learning rate into num. So this is not, you don't take it as that this is the only formula which can be applied. We have just tried to make an attempt, and the attempt is that we need to reduce the error. So that for that we need to work on the weights and biases values, and therefore we have worked on them, and we can see the significant changes in the results also. Okay, so they have been able to perform significant results. Okay, now let us go to the results part and let me execute. So here I'm executing and I'm getting here that if the score is 85 in science, if the score is 1 in social science, and if the math score is 0, then the person should the person should is not recommended to go for mathematical streams. Okay, now you can tell any of the inputs from your side. If both are 0, you can see the science and mathematics are 0, social studies is very high. You can see still the output is 0.009, like we are not at all recommending this person to go for engineering, okay, as per the records. So now you tell me, okay, so now you can tell me that hmm yeah, so any value we can put here. Okay, so if you have suggested anything, we can put that part. Let me Okay, fine. So let me put some more values here. Okay, so if I put for science I put 1, for social science I put 0.5, 50%, and for maths I put 0.5. So in this case also the student should be strongly recommended. So yes, because he is average in maths and he is very good in science. Okay, so if you see, the weights have been assigned accordingly. Whatever weights we are giving to social science, it is not much getting considered. So weight has been very low for social science. Okay, this is basically very much visible here. Even if you write anything here, anything, okay, if you write 4 here, okay, sorry, and rest of them are low, this is 0, then you can see significantly the downgrade is there. Okay, because they are you are 0. So here you have here science you have given as 0. Okay, so this is a simple example of an artificial neural network manually run. Okay, manually created. Let me just clean the output. Okay, fine. Now let me show you. Yes, let me show you the same thing with the help of a library, that is Keras. Yes. So here you can see that Keras is again a Python library, and here with the help of yes, with the help of NumPy, I have a function load txt. So I should have this file. Let me just get this file, Pima Indians dataset.csv. So I can take it from online sources. So let me just get this file. Yeah, so we have here Yes, Keras dot. So Keras, yeah, in this machine it is not installed. Okay, so I can show you the installation as well in in very few minutes. So install Keras. Okay, in Jupyter. Yes. Pip instl install. So we just need to know the proper name of the library. That's it. Sometimes versions and other things uh, are different, then it becomes a difficulty. So yes, so here we have this file. Okay, and I believe this file is having 0:8. Okay, delimiter is comma. Okay, so I can see that the kind of description here in the data set is given. It is same file. So I will download this. So let me save this file and save it in the same location where everything is present. So let me go to C and users and this and pythonml and python notebooks. So here only I'll put this file. Okay, so it is here. Yeah, it is saved, and let's quickly install. So pip install keras, nothing else I can see. So let's do it here itself. We can do it here only. So let me do pip install keras. Okay, let us install that, and then here we can see keras.models. So here we have sequential model we are importing from keras, and then layers, keras.layers, we are having dense layers. Okay, great. So it is installed. Nice. Fine. Yeah. So in case of like in case of keras, if you want, you can also work with another library which is called as tensorflow. Okay, and tensorflow comes with keras, and it again gives you multiple models. Okay, so one is a sequential model, and another I don't remember the name. I think functional model. Yes, I think the second one is functional model. Okay, so sequential model is where like we will see that here. Yes, so here we will see that how does sequential works. So now let me import this, and something keras require. Yes, correct. Yeah, so that's what I was saying. So TensorFlow we would require. Let me just install that as well. Okay, so that there is no problem of dependency. So here let me install TensorFlow as well. So pip install, what happened? Yeah, so let's wait for it to get installed. Yes, so the TensorFlow will get installed, then we'll be able to have NumPy, I think, must have got executed. So let me execute this and just check if it is getting issues, or do I need to make any changes in the file, because it has got some extra text was there I was able to see. Okay, so it will get executed once this is done. Fine. So what we can do, if it is taking time, we can explore one very useful library which can help you to deploy models locally or anywhere in the cloud also. So whenever we are working, okay, I'll come back to this and we'll show you by the time this is working. Yes, so I think it is here only. Eval, and where is it? Yes. So yes, so we have a very important, not important, very useful library, very what we can say, very useful library if you want to work on deploying your models. Yesterday this was asked, so I don't have a free access to cloud, that's why I'm showing you this you can do on local, as well as this can help you for deployment on cloud as well. So this is PyWeb.io. Okay, so this PyWeb.io can help you, and let me use this PyWeb.io to demonstrate a simple example which is given here itself. Basic input, and yeah, so we are here in users guide. Yes, so let me just introduce you with that by the time it is getting executed. Okay, so let me go up and let me create one new file. Hmm. Okay, yes. So this PyWeb.io, okay, here we will see a very simple application. Okay, this also you can install with the help of pip command. Okay, and that we need not to do because I have already done that. And in order to cross check whether I have done it or not, let me demonstrate. So this is a simple example, an example to calculate BMI, body mass index. Okay, and like without doing any kind of HTML coding as well, you can create, not you can create, you can use this particular API, and it will help you to get a beautiful user interface, a simple and beautiful user interface. So let me just import from PyWeb.io. So from PyWeb.io, okay, dot input we require. Okay, so there is a suggestion. Sometimes this behaves little slow. So from pywebio.input, we need to import input and float. So input and import float. Okay, import and input as well. Okay, and again from uh, pywebio dot output. So it has got one input module, and this is output module. Input module will create web pages for taking the inputs, and output module will help you with by creating the pages for output. Okay, like wherever output needs to be given. So let me import a function called as put text. So there is a function put button, put text is a function. Okay, so okay, put text. So these two things I'm importing here. Okay, so here you can see one is input and another is output. And let's move ahead, and let me define a function. So I'm defining a function def bmi. Okay, so this function will help me to calculate the body mass index. Okay, and here I will be taking up height, and I'll be taking up weight. Okay, and the formula is I'll be taking up these two things. Okay, so just let me just write input. Okay, and here also I'll be taking up these two things. Okay, and after that I'll be going for calculation of BMI, body mass index. Okay, which is weight divide by, and I need to do height. Okay, square of height divide by 100. Okay, and to the power 2. Okay, this way. Fine. So here let me take the input. The input is here we'll ask enter height, and in the second one we will ask enter weight. Okay, so we are asking for height and we are asking for weight, and then after that let's have, okay, so okay, yes, so this function is now taking these as input. Okay, and now we can create a list for comparing, okay, that it is like a reference list that who is obese and who is underweight. Okay, so we can have a list of that. So let's create that list. So ref list list. So reference list is there. In this reference list, I'm going to put some tuples, and let's say the BMI comes as 16. Then in that case we will have severely underweight. Severely underweight. And let's say the BMI comes as um, 18.5. So I'm just referring from net, but so if the values are not correct, so just ignore the values. So underweight, okay, so that person would be underweight. And then let's have an example. If it is 25, then the person is normal, okay. And then we can have one more condition. If it is 30, then the person is overweight. So over, WEIGST, overweight. And then let's have one more. If it is 35, okay, 35, then we can have moderately, moderately overweight. Okay, so moderately overweight. And the last one we can have, if it is coming as infinity. Okay, so float float, and here I can pass INF. So if it is coming as infinity, in that case we can tell that severely overweight. Okay, so this is a list we have created, and from this list we will calculate and compare, okay, the BMI calculated on the above, okay, by the height and weight of any user. Okay, so what I will do here for now, for B comma, and we have a message, okay. So B comma M, okay, so for B comma M in ref list, now what to do, if BMI, okay, so if BMI, which we have calculated earlier, if it is less than or equal to the hmm, if it is less than equal to your this thing, uh, your B value, okay, so 16, 18, these are the B values. If it is less than or equal to B value, in that case we can just print, okay. So here print, we need not to write print, we need to use this, okay, put text, we need to use this library, okay. So here we can use put text, okay, and inside put text we can print those things, okay. So put text is like print only, and here we can print your BMI is, here we can print the BMI, okay. And yeah, so that's a float value, so we can have a representation like percentage 1 f dot 1 f, okay. Okay, yeah. And then slash n we can have, and we can put that you are, okay, you are, and here we can print whatever is the status of that person, percent s, okay, fine. Now let us give the variable names here. So BMI first we need to print, and we need to print, sorry, we have B, uh, no, BMI only we have to print, because BMI value is coming from here. And then we need to print here the M, the message, the status. Okay, so now you can see that I have written a simple function. I have written a simple function. Nobody can even imagine, nobody can even expect that I'm doing some web programming. Okay, so this is all, if you see, this is, yeah, so this is all if you see here. Yes, that it's a simple program I have written and nowhere web programming. So I'm executing this, and now what I'm doing, I'm creating, okay, I'm just calling that function. So if name underscore is equal to main, then execute bmi. I'm executing this function, and now you can see that wait, object is not callable. Which object is not callable? Something I did. Tuple. Okay, I'm sorry. I just missed to put this thing here, and now let me execute. So here, okay, let me re-execute that. Although I have completed the code, let me re-execute that. Let me re-execute it and then try. Okay, so restart and run all. Just a second. So break. So let me just. Okay, I'm sorry. Yeah. So it's a private function. Main is a private function. So that was the mistake again I was doing. Let me correct it and restart and run all. So now it should work as per the expectation. Yeah. So here you can see that it has come up with a UI, and it is running in some local server, and it is asking enter height. So let us put height. Okay, so normally a person can be of let's say 167 is the height of a person. It is asking for weight, so let's say the weight is 58. Enter. Okay, there's still some issue. It is not giving the output. So here, unsupported type for uh, here. Okay, so let me do one thing. Let me just so here what happened. Yeah, all looks good, but okay, let's go the simple way. So here we can have it uh, ended here, and I can just write BMI. Okay, I can print BMI here, and then comma and slash n. You are this much of weight. Okay, so here I can just write. Yeah, let's go in a simple way. M. Okay, and okay, that's it. So let me just close this. So always we can take help from the errors we get. So hopefully this will work, and we'll move ahead then. Yes, so again I'm putting 167 as this and 57 as height, and again it's not giving some error, unsupported type. uh, okay, I have not done typecasting, so I should have done typecasting here. I hope you understood. So here I should have mentioned Okay, so I can just do it like this. Yeah, so this is a simple error we got, and this is float, and this also should be float. Okay, yes. Now let's rerun it, restart and rerun. Okay, so once again 167 and 57 is the, yeah. So here you can see that your BMI is 20.44 and you are normal. Okay, so what we did, a very simple code we have written here, and with the help of that simple code we are able to deploy it with the help of PyWebIO. Now you'll be thinking that how this deployment happened. So this is the simplest example, the step one we have followed for this user guide. Okay, and you can basically go through input, output, all these functions. Okay, if you wish, you can see that sample code is given here. Whatever you would like to have, you can just take it from here, and you can experiment with that. So let me just help you with the experiment, and here I can just put those things. Okay, so I have put all those sample codes which are helping us to, let's say you want to have some password field, you want to have some drop down check boxes, single choice, multiple line input. So all these things it will now ask as an input. Okay, I'll just execute this just to demonstrate. Okay, so from there documentation you can read and work upon it. I'll show you one more on this. Yes, height again, something I'll put, and weight I'll put 49, and then something happened. What happened? Password is not defined. Password is not defined. Where is it? Okay, yes, yes. So one more thing we need to input. So from pyweb, so I can yes, pywebio dot input. So let's do one thing. Import stars. So everything we'll import so that we don't get any error just because of some library, some sub module we have not imported. So I have imported everything, and now let us see it running. I'm sorry, yeah, again. Okay, so restart and run all. Yes, so yes, I'm just putting some dummy values, 45. You can see like password. So if I type something here, it is not visible. So this is a password field. This is a drop down, and here you can see checkbox, and here you can see multiple choice, and here you can see some text message. So all these fields you are able to do, and I believe you must be very happy to see this because you're not doing any kind of HTML programming. Okay, so being into analytics area, you may not, you would not like to do, or being from some other area. So I'm just selecting some file and submitting it. Okay, and lastly, I had printed only two outputs, therefore it is giving two things. Otherwise, I could have added some more things. Let me just demonstrate the same thing, like if you want to include it in machine learning. Okay, so how you can do this? Let me just show it to you here. This is the code we had done yesterday. Okay, so here I would like to show you that. Let me clean everything. Let me clean everything. Restart and clear output. So what we did yesterday, we had applied one algorithm here, and the algorithm was KNN algorithm, K nearest neighbor algorithm. Okay, so we had imported certain libraries, then we had selected the neighbors, and then we had loaded the data set. So let's keep on doing that. So the same deployment, with the help of that, I'll demonstrate here. So neighbors we have selected, then data set we have loaded here, and after that we had divided the data set into input and output. So in input we have taken only two features, and in output just a second, yeah, so in output we have all the target variables. So input and output we have taken, and then with the help of train test split we had splitted it. Then we had created a model. You can see KNN model we had created, neighbors.kneighbors classifier with neighbors as 20. And after that, we had trained the model with the help of function fit. These are standard functions applied for all the models. So this is a trick you can remember. You just need to change the model, which model you want to use. Otherwise, rest of the things, like if you just want to follow it as a thumb of rule, you can follow it that way also, for SciPy at least. Then ypred is equal to knn.predict. Now here we are getting the predictions. Okay, so these predictions, Now like my objective is that my model has already learned. Okay, मेरा model already सीख चुका है. So from that model can take any input and give any output. Okay, so now what we had tested the scores. I'm not going to that. So I just checked that like my output is my input should be an array, and an array of 2 dimensions. So what I did, I created a simple program. So this much program I have created. Look at this simple program I have created, and this program is going to is using the model which I have created. You can see knn.predict. So this is the model I had created, knn model, and it was trained, and then this model is able to predict. So that model I'm using to make the predictions, and I will take the input from the user and will make predictions. After making predictions, it will tell us that what type of flower it is it. Okay, a simple program I created. Let me execute this program and demonstrate to you. So you can see that it is asking for put the sepal length. So I know the sepal length are ranging from some 3 value to 6 value. So I'm putting very low value, 3.3, let's say. Okay, it is asking for sepal width. I'm putting it 4.3. Okay, less again. So it is telling that it is Virginica. Okay, so the predicted class is 2 and it is Virginica. Okay, now let me put some value. Okay, let me go back. Where is that iris? Yeah. So here we already know values are given. Okay, from the beginning. So this is the whole data set. We know these are the values of the first 50 are values of Setosa. So I'll give some values of Setosa only. Here we have chosen second, third. Okay, second, third record. So second, third. So some values of Setosa. So here you can see Setosa is having 1.4, 0.2. These are the records of Setosa category up to 50. After 50, we will have different. So I'll put very less 1.4 and 0.2. Let me put that. So we should get the output as Setosa in that case. Let me put that 1.4 and 0.2. This we will put. So here I'm putting 1.2 very less value and 0 point something 0.3, enter. So you can see that 1.2 and 0.3 the predicted class is 0 and output is given as Setosa. Okay, so though the UI is very simple, but yes, this can be a good way, an interesting way to explain anything, because to a non-tech person, if you will explain your work with the help of notebooks or any other software, it might not be so interesting. But yes, this can be a better mechanism of displaying your work. So this is one example how you can locally or anywhere. Other examples, as I told, cloud services are there. All of them are not free. I already utilized my 1 year subscription. So you can go for Azure and Amazon. So they give us. Okay, so if you go for Azure machine learning, so yeah, so they give us services. Okay, yes, you can create your free account and you can start deploying. Okay, here they have multiple things. Let me just show you that. I'm already logged in, but I'm not able to create free machines now. Yeah, I'm already logged in. Let me show you that section. Yeah, so I need to go for this because my subscription has over. But let me just show you. I'll see it later. Yeah. So here, app services, cost management, subscriptions. So yeah, more services, and under this see all services, and under this we can see storage, web, mobile, containers, databases, analytics. Yes. So here you can see we have analytics. In the analytics, we have multiple services, and here, like you can see, this Power BI is very much being used for reporting purpose. And below that, you can see this ML part. Okay, so in ML part, you have Synapse Analytics, bot services, cognitive services, ML Studio, Machine Learning Studio. So here you have multiple options in ML. Okay, so this you can explore, and there was for AI also. Let me just, yes. So this part you can explore in case of Azure. Okay. And as I said, like if you create a free account, you will get some of these services for free to get explored. Okay, and you'll get ready-made data and everything herein. Okay, another option could be that you can use there is a framework called as Django, that you can use, and you can use Flask. So Django or Flask, these are web development frameworks, but when once you like to deploy your models, you may would like to use Django or Flask. And with the help of Django or Flask, you can deploy. There's a free cloud you can deploy in Heroku. Okay, so in Heroku, this is a free cloud service. So here also you can deploy your Python applications. Okay, so use Flask or Django and deploy it here. Fine. So the simplest way I could see was this one. This is Python PyWebIO, Python WebIO. This was the simplest mechanism. I'll put the links on the Google Classroom. Other options I have just told. These are the other options. We just missed to do this, so it was installed. I hope there was no error. Uh, yeah, so there is an error here. So let me take another 1 or 2 minutes and just complete this. So yeah, so you always can use this as your backbone because it will allow you to install anything without much trouble. Yes. Yeah, so by the time it is getting installed, 1 or 2 minutes I'm taking more. So let me just explain you what can be done. So here also, just make analogy between the models. Okay, models means the KNN model, and here just make the, let me just, yeah, so just make the analogy. In the KNN model also, we had created model KNN is equal to, then the model name. So here sequential it is written. So model name is sequential. Then after that, if you see model dot add, and here dense. So this is a layer. Okay, dense is the name of the layer. Then model dot add, model dot add. So we are adding layers. And what sort of layers we are adding? We are adding layers of 12 nodes, 8 nodes, and 1 node, because at the end we require one output. So multiple nodes are going to give multiple outputs, and a single node is going to give single output. Okay, so this is what is happening. And then we have mentioned input dimension. So input dimension is 8. Okay, and what will be the output dimension? It will decide. Activation function is ReLU. Here also activation function is ReLU, and here activation function is sigmoid. So sigmoid is basically giving output as 0 and 1. Therefore we mostly use at the end sigmoid function. Okay, yeah, so I think it'll take some time. So yes, so here we are adding multiple layers, the way we had seen in the slide. And then after that, after adding the layers, we can compile the model. And while compiling, we need to tell that error is nothing but loss. How basically loss should be calculated. So binary cross entropy is used here. Then how it should be optimized? So optimizer strategies are there. So Adam is one of the strategy. And metrics, if we want to see, so accuracy. So whatever metrics we want to see, we can mention here. It will display all the metrics, and then it will give us the model summary at the end. After that, we are fitting the model. So in the case of KNN, we were not required to compile it. Okay, it was not needed. But in this case, if you see, this is similar to if you go to, let's say, Subway. So they will say you create your own burger, you create your own. So you will tell, okay, I need this much this much that. So your neural networks are like this because you added 1 layer, 2 layer, 3 layer. If you would choose, you can add more layers as well. That is your choice. Okay, so therefore you need to compile it, and then the model will get created. I believe you understood. So in KNN already there is one model, only one model, but here we have multiple layers, therefore we need to compile it. After compiling, the process is same. You need to fit x and y. You need to tell how many number of iterations should happen, and how much data at one time should get taken. Batch size means if you have 1,000 data sets, so 20 20 20 20 every time the data would be coming in. Then evaluate the model and make the prediction. Okay, So these are the steps. If it is done, it is still happening. Okay, consider adding warning. Yeah, fine. Let me just try running it if it has, if it can be, and then we'll close. Suppress the warning. No. So yeah, I have not got any message yet that successfully it has installed, so I believe it is going to take time. Fine, so for now we can conclude here for the day, and I will add these resources in the classrooms. You may refer there, and at the same time I can give answers, responses to any queries. You may put it in the classroom also. So I think most of you are already there in the classroom. Let me just help you with that. So here is the classroom. Most of you are already there in the classroom. So if you have any query, you can raise some issues in the classroom also. I can take out some time and I can respond from here also. Okay. Yeah, already people have, yeah, started to comment. Yes, so similar way you may comment and I can respond to your queries. Yeah, so that's it for now. Okay, so yeah, still it is giving some errors, so this resolution may take some more time. So that's it for today, and thank you for listening so patiently. Yeah, I'm done. Thank you. Is it open source? Yes, everything we did till now is open source. Everything we did till now is open source. Yeah, I think there is no other question in the chat box. Yes, everything is open source. Yeah, thank you.
Thank you, sir. Thank you very much.
Thank you, sir. Thank you very much. Yeah, pleasure. Okay. All right. So yes, Gaurav sir and Sania madam, I'm done. So we may conclude for the day.
Yeah, just a minute. I'm just
Just a
sharing my screen.
Okay, okay, okay.
Yeah, just a minute. Rashmi ma'am, you can continue, please. Yeah.
Yes, ma'am. Thank you. First of all, I would like to ask to participants to give their back on this topic on the session. Anyone participant? Okay. So, Sani ma'am, shall we proceed?
Yeah, ma'am. Yeah, please.
Hello.
Yes.
Yes.
Hello, ma'am.
Please keep your
Hello.
video on.
Hello.
Hey, you're
Yes.
audible, please.
Hello.
Yes, dear
Kushal
participant,
sir,
please
you are audible.
keep your video on. We
Hello.
would like to hear more from you people regarding the feedback of this FDP. It will help us to improve our services next time. So please give your valuable feedbacks over here. Thank you.
Hello. Hello.
You are
Ma'am, I'm
audible. You are
audible,
audible.
ma'am.
Yes,
Okay.
yes, you are
I'm
audible.
Mr. Okay. Okay. I'm Mr. Kushal Mange from GH Raisoni College. I would like to thank DY Patil School of Engineering and Department of ENTC and Mr. Kushal Sharma for organizing this workshop. All the sessions were very well organized organized, and the content of the sessions were simply pristine. And I'm sure that the session is helpful for all participants who attended this 5-day FDP. I once again like to thank the DY Patil School of Engineering and Mr. Kushal Sharma. Thank you, sir.
Good afternoon, sir.
Thank you very much, Ashwin sir. Any other participants?
Yeah.
Yes.
I think someone wants to do the feedback. I think it's a Dr. Bhavani, ma'am. Yeah, ma'am, please.
Yeah.
Please keep your video.
Good afternoon.
Yeah,
Am
good
I
afternoon,
audible,
ma'am.
ma'am?
Yes.
My special thanks and congratulations to the entire team of Electronics and Telecommunication Engineering Department from Dr. DY Patil School of Engineering. In this pandemic situation, you have organized a very nice FDP. So far, I've been attending a lot of FDPs being arranged on Atal FDPs, being sponsored by AICTE. I could see almost the sessions being only on theoretical aspect. But here, all the 5 sessions, whatever I have attended, actually I thought of attending only for half an hour, right? But it actually made me to attend the whole session, as the entire sessions on all the 5 days were online. So all the professors have been handling the sessions, whether it is the today's session on the neural network by the professor who made everything online with the online tool. He was explaining the neural networks, including the SOM concept, feed forward networks, etc. And also yesterday's session and day before ontology sessions by the professor, and the very first introduction, very first day we had on artificial intelligence, which was right from the basics. Sir was explaining with lot of examples and the classifications, what are the 6 AIs we have, everything. It was very nice, and happy also to see that all the session materials were uploaded in the Google Classrooms. My special thanks and congratulations to both Professor Tiwari, Gaurav Tiwari, and also Dr. Sania Ansari. Thank you for the opportunity given to attend, as well as to share my opinion on the feedback about the sessions. Thank you so much, ma'am.
Thank you. Thanks a lot, ma'am. Surely we'll upload all the materials, record materials, and thank you for your feedback, ma'am. Thank you.
Ma'am, this is Hemalata from Bharat University. I was attending this workshop from 2nd onwards. Actually speaking, first day there is no power, so I couldn't able to do it. From 2nd onwards only I'm attending this session. I was asking a request. You have to conduct the FDP on neural networks, how neural networks is being used in artificial intelligence, etc. So as a participant, my request also is taken into consideration, and they have done that in today's session. Thank you very much, Patil sir, for that consideration. And I have to thank organizers also, Tanya ma'am, for sending the feedback, for sending the link, and whatever request we are keeping, everything is fulfilled, ma'am. Thank you for organizing such a wonderful.
Thank you. Thank you. Thanks a lot, sir. Thank you.
So any other participant would like to say something?
Yes, ma'am. Myself, Komal Bhole from Srimati Kashibai Navli College of Engineering, and I would like to thank all the team of DY Patil School of Engineering Electronics Department, Sania ma'am, Sanjay sir, Rashmi ma'am, and the rest of the team for organizing such a wonderful session for 5 days. All the 5 days were very informative, especially for the ones who are going to research in this areas. So all the basic terms were made very clear. Thank you very much.
Thanks a lot, Komal. Thank
you. Any other participants would like to say something?
Hello, this is Dr. Ranjan Mishra from Greater Noida Institute of Technology, Greater Noida. I would like to thank a special thank to Mr. Kursal sir, Sanjay sir, and Sania madam for organizing such a wonderful and practical FDP. I would like to congratulate you and request you to, I think, one more FDP is needed to go into the further concepts.
Sure, sir. Sure, sir. We'll try, sir.
We will organize an advance of FDP on the same topic also. Thank you very much.
Sir. Thank you, sir. Thanks a lot, sir. Sure, we'll take care.
Any other participants would like to say something? There is one announcement for the participants. We are arranging one short quiz based on our program. So this announcement has already been done. But still, by today evening, if you could please reply to that quiz, it will be really great help for us. And also, we have shared the feedback link. You can give your true feedback over there. So, thank you very much, participants, for being here. So now moving towards the concluding part of the session,
Excuse me,
that
ma'am.
is
Sorry for the
vote of
interruption.
thanks.
Ma'am, sorry for the
Before
interruption.
going
One
to the
second, ma'am.
conclusion,
Rush ma'am, I think Dr. Hemlata, she want to say something.
wants to,
Ma'am,
yes,
we'll
yes,
send
ma'am.
it. The quiz will be sent, right, ma'am? You will be sending it to the mail ID, right, ma'am?
Yeah.
Yeah.
Can you, ma'am, please repeat?
No, ma'am. Actually, you said quiz will be sent to all the participants, right? It will be sent to
Yes.
mail ID, ma'am.
Yeah, I will send it
Yes,
to
ma'am.
through email.
Okay, okay, ma'am. Thank you, ma'am.
As well as we will share same link on the WhatsApp group also.
Yeah, okay, ma'am. Okay, ma'am. Thank you, ma'am.
Yeah. Yeah.
And FDP certificates we are going to distribute by maybe tomorrow or 1 or 2 days. So have a patience for that. So moving to the conclusion part of the session, I would say good afternoon, everyone. It's my really privilege to propose a vote of thanks and acknowledge the contribution. Yes, sir. Yes,
Let
sir.
Kushal sir, let Kushal sir keep his camera on. Kushal
Yes.
sir.
Yeah. Just give me
Yes,
1 second.
all the participants can keep your camera on so that we can have a group photo virtually.
Yes, sir.
Swati ma'am, please have a snapshot, screenshot of this one, please.
Yes, madam.
Yeah. Thank you.
Rashmi ma'am,
Yes, sir.
before you start the valedictory function, shall I
Yeah.
say a few words?
Yes, sir. Please, sir. You
Sure,
are
sir,
welcome.
sure. Sir, please,
Okay.
you're most welcome.
Okay. Good afternoon, all. We are on the verge of completion of this 1 week FDP on AI, where Kushal sir has given you the in-depth knowledge of theory as well as hands-on, maybe in online mode, where we have some restrictions of number of hours being in online mode, but still Mr. Kushal Sharma, who is the director of Kushal Technology Private Limited Pune, might have expressed his total knowledge to you, and that would be useful to you. So I think during these 5 days, you might have enjoyed all the levels, starting from the beginning of the concepts till the end. So I would also like to thank Sanya Madam, who is the coordinator for this FDP. And
Thank
in
you, sir.
future, I will be happy to welcome you all participants, maybe some advancements in AI, topic with some advancements in AI. We will try to arrange it. Okay, thank you very much. Thank you, ma'am. Please, it is over.
Thank you, sir. Thank you, sir. Thank you very much, sir. So once again, I acknowledge the contribution of those who worked really hard to make this event successful. On behalf of Dr. D.Y. Patil School of Engineering, Logaon, ENTC department, I, Dr. Rashmi Mahajan, would say thanks to our speaker, Mr. Kushal Sharma, for very informative and I would say energetic sessions. So his sessions were full of energy since from 11 a.m. up to 1 p.m. So thank you very much, sir. And sir, we are sincerely thankful to you and hope that in future you will be there to guide our participants and the interested students also, I would say, in the domain AI. So thank you very much, sir. And thank you full to our honorable chairman, Dr. Ajinkya D.Y. Patil, sir, and management for the consistent support for this event. I must say thanks to Dr. Ashok Kasnale, Principal, Dr. DY Patil School of Engineering, Lohega. And my sincere thanks to Head of Department, Professor S.M. Kodi, for continuous encouragement to the staff, even in this pandemic situation. I'm sincerely thankful to the event coordinator, Dr. Sania Ansari ma'am, and all the organizing committee members for the efforts taken for the conduction of this event. In this lockdown situation also, I must say, and I must be very thankful to all the participants for patience and for being present for the workshop for all 5 days. So thank you very much to all. Thanks, sir. Thank you very much, ma'am. And thanks to everyone. So we will conclude our session, and we will hope that DY Patil School of Engineering will again arrange such workshops, and all the participants will rejoin, as sir said. So we will conclude with this concluding note, sir. Thank you very much.
Thank you.
Thank you very much. Thank you.
Yeah. Thank you, Rashmi. Thank you. Thank you all participants.
Thank you.
And thank you, Kushal sir.
Welcome. Thanks a lot for giving the opportunity.
Yeah.